All right, we're going to talk about modeling with quadratic functions. So if you remember what a model is it's just a representation of a real world problem. Okay, so now we're going to use quadratics to model those. So we're going to be talking about rockets. If you're into football, you see it when they punt the ball, you have a quadratic as the ball's traveling. So there's lots of parabolic models that we can use. We're going to keep it fairly simple. So the first one is, how do I get to an equation if I'm given 3 different points on the parabola? Okay, so we're going to show that. So what is the equation of a parabola in standard form with the points 0, 0, -1, -2, and 1, 6? Well, the first thing I have to do is I have to plug in all of these points so that way I can see the different equations. So the first one I have is 0 equals a times 0 squared plus b times 0 plus c. Okay, so this is my first equation. My second equation is going to be -2 comma a times -1 squared plus b times -1 plus c. And then my third equation is going to be 6 equals a times 1 squared plus b times 1 plus c. Well, in my first one, this one becomes pretty simple to solve, right? I have 0 equals, well, 0 squared is 0 times a is 0, 0 plus c. And so now I have c equals 0. Okay, so I found my first variable. It's not always going to be that easy. Okay, it is in this case because I have 0, 0. But if I had another set of numbers here, I would have a, b, c. Okay. Now on the next one, I have -2 equals a minus b. And on the third one, I end up with 6 equals a plus b. So, well, and we actually have plus c, but c is 0. So I get to substitute in what c is. So I get -2 equals a minus b, 6 equals a plus b. If I had c's in there where c wasn't 0, so if I had a third equation here, I would have to solve 3 variables with 3 equations. So remember, if you remember that, we'd have to combine 2 of these, use the third equation and combine them, so that way we get rid of one of the variables. So then we would have 2 equations, 2 variables. All right, but on our problem, we already know c is 0. So now I need to find a and b. Okay, well, I look at my 2 new equations. I notice that I have a -b and a positive b. So I can actually combine these straight up and down. Okay, so this is going to give me 4 equals 2a or a equals 2. So now I have a equals 2, c equals 0, and now I have to find b. Well, to find b, you can use either of these equations. You can actually use any of these equations and find b. Probably won't use the first one because it's all zeros. But I'm going to use this one here because then I have a positive b. So I have 6 equals 2 plus b. Subtract off my 2, subtract off my 2, 4 equals b. There is b. Now I can put it into my standard form of ax squared plus bx plus c. So I have y equals 2x squared plus 4x plus 0. I'm not going to write the 0. And there's my equation in standard form. Okay? So we want to make sure that we can be able to find these. It's nice if they have 0, 0 if it's going through the origin, because then we know that c has to be that number. If this was 0, 5, we would know c has to be 5. So that would also be nice, okay? So as long as I have an x of 0, the next number tells me my c, okay? So here's a model. It says the path of rocket 1 follows a path of h equals -16t squared plus 150t plus 1, where t is time in seconds. Okay, so this is the height function. So this rocket is following along this path of launching, okay? And so what is the maximum height of rocket 1? So remember we said the max and min has to occur at the vertex, okay? So the vertex, so I need to find my vertex, okay? So that's the first thing I'm going to do. So I need to find my x-coordinate, and that's going to be negative b over 2a. Well, I probably need to write down a, b, and c. So I'm going to do that here. A, b, C. A is negative 16, B is 150, and C is 1. Okay? So now I'm going to plug this in here. So negative B is negative 50 over 2 times negative 16. So that gives me negative 150 over negative 32. All right? So I'm going to find out what this is in decimal form. And that's going to give me this is going to give me 4.6875. Okay, so I'm going to write that in here. 4.6875. Now I'm going to take this value and I'm going to plug it in up here because I need to plug it in to find my y. So I'm going to go negative 16, 4.6875. squared plus 150 times 4.6875 plus 1. I'm going to plug this into a calculator. Times 4.6875 squared plus 150 times 4.6875 plus 1. And I get a height, or we get a y of 352.5625. So this is 352.5625. So I'm not done though. It says, what's the maximum height? So my maximum height is 352.5625 feet. Okay? And it's going to occur 4.6875 seconds after launch. Okay? So this, remember, this is my maximum height. This is when, at what time that height occurs. The last thing I kind of want to talk about is if I plug in 0 here, I plug in 0, I get 1, right? So if I have this, I have the point 0, comma 1. What does this actually mean in regards to the path of our rocket? At time 0, it's at a height of 1. Well, understand that what that's saying is like the platform that it's sitting on is 1 foot above the ground. So it's going to launch at a height of 1 foot above. And so it's going to go up, come to the peak, drop back down to a height of 0. Okay? Are we going to have heights of negative values? So if I plugged in like 100 and can I have a negative height? No, because understand what this is saying. A negative height would say that we're going into the earth. Okay? So that's using modeling and understanding there's different pieces on this and what we're trying to look after.